Hi everyone, welcome back to Tech2Dev, where we simplify electronics for everyone. In today's video, we're exploring transformers. What are they? How do they work? And why are they so essential in electrical and electronic systems? Let's find out. Okay, what is a transformer? A transformer is an electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. It's primarily used to change voltage levels, either stepping up or stepping down, depending on the need. Transformers operate on the principle of Faraday's law of electromagnetic induction, which states that a changing magnetic field induces an electromotive force in a conductor. Transformers come in various types based on their application. Here are the most common ones. First, let us see step-up transformers. The step-up transformers increases voltage from the primary to the secondary winding, commonly used in power transmission. The step-down transformers decreases voltage from the primary to the secondary winding, found in household appliances. Isolation transformer. The isolation transformers provides electrical isolation between circuits without changing voltage. Okay, let us see parts of a transformer. Let's break down the main components of a transformer. Core of a transformer. The transformer core is a critical component that provides a path for the magnetic flux, enabling the transfer of energy between the primary and secondary windings. It is designed to maximize efficiency and minimize energy losses. The core is usually made of laminated iron sheets to minimize energy loss. Thin sheets of steel are stacked together, insulated from each other to reduce eddy current losses. These metal plates provides a path for the magnetic flux. Using materials such as silicon steel reduces the power loss caused by the magnetization and demagnetization of the core material. This type of loss is called hysteresis loss. By laminating the core and insulating the layers reduces the power loss caused by circulating currents induced in the core by the changing magnetic field, and this type of loss is called eddy current loss. The transformer core is essential for efficient energy transfer, and its design is tailored to meet specific application requirements. The windings in transformer. The windings are copper or aluminum coils wrapped around the core. The primary winding connects to the input voltage, and the secondary winding connects to the output load. Insulation used in transformer. Insulation prevents electrical contact between windings and the core. Transformer formula. Ever wondered how transformers step up or step down voltage? Let's break it down with one simple formula. The formula is Vp by Vs equals Np by Ns. Vp is the primary voltage, and V is the secondary voltage. Np is the number of turns in the primary coil, and N is the number of turns in the secondary coil. This means the voltage ratio is directly proportional to the turns ratio. For example, if the primary coil has 100 turns and the secondary has 50, the voltage is halved. In secondary, let us check an example. Let's say the input voltage is 220 volts and the primary coil has 100 turns while the secondary has 10. Using the formula Vs equals Vp times Ns by Np, we get Vs equals 220 times 10 by 100 equals 22 volts. And that's how transformers work. Simple math for a powerful tool in electronics. Like and follow for more quick tech tips. Now let us check the types of transformers. Transformers are vital in many applications. Let's look at a few examples. Transformer uses in power transmission. High voltage transformers are used to transmit electricity over long distances efficiently. Transformers uses in power adapters. Step-down transformers and adapters convert high voltage to low voltage for devices like laptops and phones. Transformers have traditionally been used in power supplies for voltage regulation and isolation. However, switch-mode power supplies, SMPS, have increasingly replaced transformers in many applications due to their efficiency, compact size, and versatility. Transformer-based power supplies are bulky and heavy, and switch-mode power supplies, SMPS, are compact and lightweight. Traditional transformers operate at mains frequency, 50/60ths of a hertz, requiring large iron cores and copper windings, leading to significant energy losses. SMPS operates at high frequencies, 20 kHz to several MHz, enabling the use of smaller transformers and reducing energy losses. Transformers are still used in specific applications, requiring simple, robust designs, such as in industrial power systems and isolation. However, SMPS has become the dominant choice in modern electronics due to its superior performance and adaptability. Use of transformers in audio systems. Audio transformers are used to match impedance and isolate signals in audio equipment. Transformers used in renewable energy. Transformers play a key role in solar and wind energy systems, ensuring proper voltage levels. Let us see how to test a transformer for safety and functionality. Identify the primary windings. Locate the primary windings of the transformer. These are the terminals where the AC input voltage 220 volts is connected. Check continuity of primary windings. Set your multimeter to continuity test mode, often represented by a sound wave or diode symbol. Connect the two probes of the multimeter to the two terminals of the primary winding. If the multimeter produces a continuous beep, it indicates that the primary winding is intact, with no breaks. This means it is safe to connect to an AC power source. If there is no beep, the primary winding is broken, and the transformer cannot function properly. Check for high voltage leakage to the core, to ensure there's no dangerous voltage seepage from the primary winding to the transformer's core. Connect one probe of the multimeter to one terminal of the primary winding and the other probe to the transformer's metal core. If the multimeter does not beep, there is no leakage, and this part of the transformer is safe. Repeat this test with the other terminal of the primary winding. If you hear a beep during either test, it indicates high voltage leakage to the core, which is extremely dangerous. Do not use the transformer in this condition. Check for short circuits between windings, to ensure there is no short circuit between the primary and secondary windings. Connect one probe of the multimeter to one terminal of the primary winding and the other probe to any terminal of the secondary winding. If the multimeter does not beep, the windings are properly isolated and the transformer is safe to use. If you hear a beep, it means there is a short circuit between the windings, which makes the transformer unsafe for operation. Safety notes. Always perform these tests before connecting a transformer to a power source, especially when dealing with high voltage inputs like 220 volts AC. If any of the tests indicate a fault, no continuity, high voltage leakage, or a short circuit, do not attempt to use or repair the transformer which works on high voltage. Let me show you how to test a transformer. Connect the primary windings. Take a cable with a plug and securely connect it to the primary windings of the transformer. Ensure the connections are tight and reliable. Since we are dealing with a 220 volts AC power source, use insulation tape or heat shrink tubing to cover the exposed connections. This step is crucial for safety to prevent electric shocks or short circuits. Identify the secondary windings. Inspect the secondary windings of the transformer. If you notice 3 terminals, it indicates that the transformer is a center tap transformer. In a center tap transformer, the 3 terminals typically represent 12 volts, 0 volt, it is the center tap, and another 12 volts. This configuration is often labeled as 1, 2, 012. The center tap 0 volt acts as a reference point or ground, which I will cover in detail in another video when we discuss how to build a rectifier circuit using a transformer. Test the output. Connect a 12 volts LED light to the secondary windings of the transformer. You may get a query that while LED works with DC, will it work? If you have any query, please write in comments. Once connected, power on the transformer by plugging it into the AC power source. You should see the LED light up, indicating that the transformer is working correctly. Safety reminder. Always handle transformers with care, especially when working with high voltage inputs like 220 volts AC. Double check your connections and use proper insulation to avoid accidents. Transformers are essential for voltage regulation, electrical isolation, and efficient power transmission. They're a cornerstone of modern electrical systems. If you found this video helpful, give it a thumbs up. And don't forget to subscribe for more electronics tutorials. Thanks for watching, and I'll see you in the next video.